Invented in 1950 by Eugene Houdry, a French mechanical engineer, the catalytic converter was a result of Houdry's expertise in catalytic oil refining. However, leaded fuels used in old automobiles rendered catalytic converters nearly useless as the lead would coat the surface of the catalysts. Further development by a series of engineers over 25 years and the switch to unleaded fuels in 1970 finally allowed catalytic converters to be widely used. These developments included the invention of the three-way catalytic converter, the successor of the two-way catalytic converter, by being able to reduce nitrogen oxides. This was a crucial development, as nitrogen oxides have a profound impact on human health and the environment, mainly due to their contribution to acid rain. Gasoline used by cars is composed mainly of hydrocarbons, organic compounds made up of only hydrogen and carbon. To release energy, these hydrocarbons undergo a combustion reaction, which is a reaction with oxygen gas that can either be complete or incomplete. In a complete combustion of a hydrocarbon, such as octane, there is an excess amount of oxygen, meaning all octane molecules will be able to react with oxygen, producing only carbon dioxide and water. Engineers try to ensure complete combustion occurs as consistently as possible in an engine's piston. However, the conditions within an engine are not controlled, and quantities of oxygen vary constantly. As such, this allows for incomplete combustion to occur, in which there is not enough oxygen to react with every octane molecule. This reaction releases carbon dioxide, carbon monoxide, water, and any unconsumed hydrocarbon molecules. In addition, the high amount of energy released from the combustion reaction accelerates a reaction between nitrogen and oxygen in the air to produce nitric oxide. When released into the environment, the nitric oxide is exposed to oxidants and turned into nitrogen dioxide, responsible for the brown smog in polluted areas. With so many pollutants produced from an engine, it is up to catalytic converters to keep our skies as clean as possible. First off, a catalyst is a substance that causes and/or accelerates a chemical reaction without being consumed in the reaction itself, meaning they are neither product nor reactant. Within a catalytic converter, a ceramic structure is commonly coated in platinum, rhodium, or palladium. The catalyst accelerates specifically redox reactions with oxygen, the losing and gaining of electrons between two substances. The loss of electrons is known as oxidation, while the gaining of electrons is reduction, thus redox. An acronym for this confusing terminology is LEO the line goes GER, where LEO stands for loss of electrons, oxidation, and GER stands for gain of electrons, reduction. The first pollutants are carbon monoxide and unconsumed hydrocarbons. Using a catalyst, carbon monoxide and any unused hydrocarbons are oxidized into carbon dioxide, while oxygen is reduced and converted into water. As such, what were once extremely harmful substances are now turned into inert water and less harmful carbon dioxide. The second pollutant is nitrogen oxides. In this reaction, instead of the pollutant being oxidized, it is instead reduced. As such, the nitrogen oxide gains electrons and in turn loses oxygen. The result is a dissociation into inert nitrogen and oxygen gas. It's without a doubt that catalytic converters are one of the greatest automotive advancements of all time, and have fulfilled their purpose of reducing the levels of smog and air pollution in vehicle-dense environments. In the process, catalytic converters have been found to convert 90% of unused hydrocarbons, carbon monoxide, and nitrogen oxides. Despite its many benefits, however, the main byproduct of the catalytic converter process, carbon dioxide, is still the main contributor to climate change. Solutions to this crisis could be a switch to electric vehicles, researching more fuel-efficient engines, or even further research into catalytic converters. It is just a matter of feasibility. In all, catalytic converters were a major milestone in the automotive industry, and it goes to show how chemistry plays an important role in our society.